The next task is to...
Have we finished the task? Okay, so as I've been told, I have to continue. I have to run an ordinary least squares report. Okay, so first we are going to import stats models, whereby these are statistic models formulas, whereby we will be running any model which you want to run. You import the stats models formula API as SML and import pandas as PD, as we've been doing all this time. So the model, whereby you specify the model, is equal to a code whereby we say SMF stats models dot OLS. So by we are specifying it to perform ordinary least squares on the following data, whereby we have weight as our dependent variable equal to, this is what we use. Instead of using an equal sign, it will use another code, whereby it will be, we have independent variables which are education plus experience plus female plus tenure, whereby it will be data is equal to df. Then we have results, whereby the model which I have specified in this, it should be fitted. Then print results summary, which when we run the code, it will produce the following results, whereby it will give us a summary of the ordinary least squares regression results, whereby it shows us the R squared here. As you can see, if you are coherent with econometrics, you can interpret all these results. Yes, exactly. What's our next task, Cynthia?
Our next task is to run diagnostic test and explain the results.
Okay, so as you can see, we are going to use the following code, whereby we use from stats models dot stats API, whereby these are test statistics, which are the diagnostic tests, which are test statistics, and whereby we import the function whereby we use heteroscedasticity using the Bush-Bargan test. So if results in logos, which is the output which you got from the OLS model above, and results is not none, whereby it's defined, the results are defined and there's data in there. So we perform diagnostic test, which is the Bush-Bargan, whereby we equate the residues equal to results residues, which is the model has the residues which are defined, then exogenous variables which are equal to results dot model dot exogenous, these are the independent variables, if I'm not mistaken. Then we use the BP test statistics, BBP value, if test statistic, if p value, and is equal to test is equal to heteroscedasticity Bush-Bargan residues. Now we're going to use these codes, then the output is going to come out of this. So I'm going to have Chimwemi Majanga to explain the outputs. Hereby you have to explain what does this mean exactly. Hereby we have the p-value is equal to this, is equal to 0.00.
The p-value is 0.000, which shows the presence of heteroscedasticity.
Yeah,
Therefore,
exactly.
we rejected the null hypothesis.
Exactly.
So we go on our next task. What's our next task?
On just correction, we are still on the same task, and we are going to another test that we ran. Now let's see the next task.
The next test, it's the variance reflection factor, whereby we test for multicollinearity. So this is the code which we used. So it's exogenous data, whereby the independent variables, whatsoever, as you can see, independent variables, we use this command. In this case, we just use this code, whereby you can follow up, as you can go over this video and see where you make mistakes. So when we run the code, it produces this matrix or this table, as I can say. So I'm going to leave it to Joe Banda to explain the table.
Since the values of the VIF shows that there is less than 10 on all the independent variables, this shows that there is no significant multicollinearity.
Exact. Okay, so we are going to another test, which is the normality test. For the normality test, we are going to use this line of code. It's not a very long code as it seems, whereby this part it will produce a histogram, as you can see, SNS plot, and as in this one it will be a QQ plot. As we go on, we can see the Jackie pair test, which tests for skewness, ketosis, and the rest, whereby it prints the ketosis, whatever in these commands, in this code. So as we run the code, I mean, it produces the following output. So I'm going to leave it to Ruben Tubanyama to explain it for us.
Well, I'm gonna comment on the normality using the p values that we obtained. In conclusion, having obtained the p-value of 0.00, we reject the null hypothesis because it is less than 0.005. Therefore, we conclude that the residual values are not normally distributed.
Exactly. So we can continue to another task, which is no, it's not a test. It's another task.
After running the diagnostic test, then we learn a logit regression. So the task says, learn logistic regression to predict birth weight based on age of a mother, race, and smoking during pregnancy, using one IBW dataset, web use LBW dataset.
Okay, so to perform this task in Google Colab, right, we are going to first import the data file. So in this case, we are going to repeat what we did by importing the other data sets. So it has been successfully loaded, and these are the first 4 values in the data set. So when it comes to the task in hand, so we are going to first define the x and the y variables in that case. Then we specify which ones are categorical and which has a numerical in the x variables, whereby race and smoke, the categorical features. Then we go on to use these other codes to produce some. The output is going to come out like this. So we have isolated the variables we are going to be using in our model. So the model, as I already said, when we're trying to make a model in Google Collaborator, we use import stats models .formula.api as SMF. Then we go to formula LBW, whereby we are trying to show the model that is going to be run, whereby low is a categorical variable as we do in logistic regression, and these are the matrix of all the independent variables. Okay, so here's the output. Here's the summary of all of the model. Then we go to our next task.
Our next task is to calculate marginal effects.
So to calculate marginal effects, we are going to use this code, a very simple one. So we are going to run it, and here's the marginal effects. What's our next task?
This is our last task, and it says we should run a probability model and predict the following variables: pollen based on weight and mileage using auto dataset.
Okay, so we import another data set. I've already explained on importing a data set. Then I print the data frame so that I can know which are the categorical variables and whatsoever. And I continue to the model now, which is the task we have been given. So here's the code that we're going to be using. So here's the output. Here's a summary of the probability model. Then we check the marginal effects. The marginal effects, here's the code we were using. So it's marginal effects, whatever, just as we did in the logistic regression. And here's our output. So this is the last video.